Well, hi, and thanks for joining me in my shop. Actually, you're joining me and Shadow here this morning. So what I'm going to do, what I intend on doing, we'll see what I actually do in the end. I'm going to install these three capacitors to replace the three electrolytic capacitors that are in there. Then I hope to play the set, find out what happened with the speaker and my crazy repair on that, and see where we are after that. So that's my plan today. I'm already being distracted by the cat. Look, I printed out the schematic here, parts list. Okay, and look at this fantastic rock, which I'm not going to show you, but I spent at least an hour standing here with my magnifying glass looking at this rock. This is really an interesting rock, but not for today. Found that on my yard. I just found it out on my property. Okay, now, mysteries in this radio are getting bigger, not smaller. So, power supply, battery operated radio. What are you talking about, Mr. Schematic and radio? So, like on the schematic, shows 6 volts battery input, shows a cable connector going to this separate chassis, because I think that's what that shows. Why have I got 2 here? Okay, mysteries abound. Doesn't matter anyway. None of this exists in this radio. This radio has a power cord hooked up to it. So all I can guess, well, it gets weirder. Over here is this plaque that says battery operated receiver right on the plaque. So how do you end up with a radio with a plaque like this on it that clearly is not battery operated? So one way is you convert the radio. You add more stuff to it, remove the battery stuff, install what you need. There's no way that happened. This is not a botched up radio at all. This is a factory built, right out of the factory radio. There's no evidence here that this was anything other than what it is right now. So how do you end up with this on the back? So, you know, battery operated receiver, model 93, model 93, battery operated. There's no rectifier tube on here, but there's a rectifier tube in this radio. It's right here. It's a 5.4. In fact, let's expand the mystery. So when I looked at the schematic first, I was kind of taken aback by some of the tubes that are on this. RVC 15, RVC 6A8. Okay, I know what a 6A8. I've certainly seen a few of those. RVC 15. This is RVC 6Q7G. Okay, 6Q7. I've heard of that. 6C5. I think I've heard of that. But 15. And then out here is an output tube 19. But look, this radio's got a push-pull arrangement here with two identical tubes. Yeah, right. 2 identical tubes, eh? So what I decided to do was pull all the tubes out last night. I came in here in the evening, pulled them all out, cleaned them up so they look nice, stuck them all back in, and labeled what they were. They don't match the schematic. Surprise, surprise. So here's what I get out of this. This is a 6K7M. There's a second 6K7M located here. Okay, this is the mixer tube. This is the mixer tube, 6A8. It is a 6A8. There's a 6A8 there. But there's no 15 here and no 15 here. Perhaps 6K7 is a replacement for a 15. I haven't looked into this yet. But that's what's in there. 6K7, 6A8, 6K7. Here where it says 6Q7, there is a 6Q7 there. Okay, pay attention to me now. Don't let the cat distract you. Well, then we have the last 2 tubes. On the diagram here, they look totally different. They're not push-pull at all. This output one is it says RVC 19. I don't know what that is. The actual tubes that are in there, this is a number 42. and this is a 6F6. I'm familiar with a 6F6. I don't think it looks like this inside. You can't quite see what it shows, but this tube, RVC19, is a double triode. So you could use a double triode in a push-pull arrangement with a transformer like that. Voila, push-pull output from one tube. When I looked, I thought, wow, there's two tubes here. It must be push-pull done with two tubes, which is a little more common because the two tubes are identical. If you actually look inside, they look very, very similar. So my next thinking was, well, maybe this is push-pull output, and one tube's been substituted. But that can't really be the case because the base of these two tubes is entirely different. This one is an octal tube with a plastic key pin in the middle, and this one doesn't have that. This is actually I think it's a 6-pin tube, 6 or 8-pin tube, but no center post. I got them backwards. This is the one with no center post, and this is the one with the center post. They're totally different. They're both wired right up in here, of course, close together. And so the point is they're close together, so no doubt they have something to do with each other. One may be the driver of the other. So what am I left with? I'm left with a power supply in here and parts that don't show up on the schematic. Tubes being used that sure seem to be different from the ones that are in here, but maybe not. Maybe they're legitimate substitutes. So that makes me a little nervous. If this was a battery-operated radio, then it may have special tubes designed to draw very little current through the heater because you're running off a battery, and so the efficiency of the radio becomes a big issue. So there could have been some special tubes in here I'm not familiar with, like a RVC15. Maybe that's what it is. I don't know. I tried to find something about this. I couldn't find a tube number 15. Never heard of it. Couldn't find it, and there isn't one in here. So another comment about this. All these tubes I think are a little scarce. 6K7, 6A8. One of these is supposed to be shielded. Here's another thing I noticed. The 6K7s, I'm going to have to pull one of them out here. No, you can see it right there. So the 6K7 has a shield sprayed onto the outside of the glass here. This is a metal covering, if you like, it's been sprayed onto the glass. This is grounded. There should be a pin at the base which is actually connected to this outside shield. So the other one is over here. If you notice the base here too, there is a shield cup in the base. It comes up a distance and stops. Now this one here, the 6Q7, coming across in the camera, can you see it's not quite set down tight to the chassis here? It's not pushed all the way down because it's running into these clips. There's a clip here and there's another one on the back side. Two clips like this. What are they looking for? They're looking for a metal can to come down. A shielding can. Now, this is a metal tube. I mean, it has a glass tube inside it, but it's metal on the outside here. That's decent shielding. But obviously this is not the exact tube they plan to have plugged in here. So what's that all about? It's possible these tubes are mixed around. You know, this stuff happens. If people pull tubes out, they shove them back in. I've even seen people switch tubes around or introduce another tube. Doesn't matter what the name is, as long as you can plug it in. Let's give it a try. I've seen that happen. That's not a very good approach, believe me. So there's the situation with this radio, which makes me a little nervous going forward because it's a good chance the schematic I've got here is way off in all respects. In fact, this really may be the schematic for another radio, really. I don't think so, but I don't know so far. We'll just keep working away and comparing the components and things we come across to the schematic, and maybe we'll find out it's largely correct. This funny little guy here caught my attention. That's this thing right here. So this looks like a simple, this looks like a complicated on-off switch, opening a couple circuits at the same time. In a lot of battery-operated radios, you have a number of batteries. You have a couple of 45-volt batteries together producing almost 100 volts. You got a lower voltage battery for the heater. And a lot of these battery-operated farm-type radios, which are never this big, by the way. You can't run this off a battery. But when you turn the switch, you can actually be operating two switches. Like it's a single switch with two poles, and you're interrupting separately the battery going to the heater and the battery going to the two 45-volt batteries. Sometimes in some radios they don't even shut the power off from the high voltage batteries. They leave it laying in the radio because once the heaters are off, it's all open circuit as far as the battery is concerned anyway. So that's what I think this is. There's a multi-switch, but wait, there's only one battery supply. 6 volts. 6 volts. You hook up a 6 volt, it's got to be a car battery. So you hook up a 6 volt lead acid battery here, and somehow off of that you got to get 150, 200 volts. Where are you going to get it? So, well, it uses 2 vibrators here. I won't go into how these work. You can look it up if you've never heard of such a thing. But this is done in old tube car radios a lot. They use a vibrator to chop up the DC and make fake AC. Fake AC. You never know where the fakes are these days. That's what this is, except it's got 2 vibrators, but a complicated arrangement there. But of course this doesn't exist on this radio. But according to this schematic, this radio could be fed from a 6 volt battery, producing all of its internal voltages on its own from the single battery. But boy, I would think it would kill that battery pretty quick. Now these tubes, I don't think there's anything special about them in terms of current drain or at all. So I don't know. It's a curious situation. That's enough talk, eh? Now, time to do something here with this radio. Right, so what am I doing? Of course, I'm going to work right on the power supply right away. This is one filter capacitor, this is the other filter capacitor. Both these look like they've been replaced previously, and I'm going to do them again. There's the replacements, these little guys here. These are 22 microfarad at 400 volts. They can certainly do the job. On the schematic, without actually looking directly at them, there's one electrolytic there. That's my cat doing his nails. One there, one there. This is the bypass on the cathode resistor. That's this one up here. And there's another one down here, C41. These are all around 10 microfarads on here, like on the parts list, 10 microfarads. But what I'm finding in the radio, this is a 20, and this is a 20 here. So, but the capacitors on that schematic are based on a battery-operated version, and how much filtering do you need in a battery-operated radio? Well, you need some, because the output coming from these vibrators is choppy. It's choppy. It's going to be noisy. It's going to be hummy. It's going to be buzzy. Maybe that's the best word for it. So you do have to filter. And probably not the last. The other weird thing is, so is there a field coil or is there not in the power supply? So since there's no power supply shown here, there's no 5Y4 rectifier, the big honkin' transformer that's in this radio is not shown here, unless it's this thing, which I don't think it is. I think it's a totally different. So, anyway. Wow, okay, now that I've gone over that, I really have a lot of doubts. And, hey, where's the third capacitor? Hey, you cat. He took it. Oh, there goes another one. He's taken one of my capacitors away. Where did you go with it? It is missing. That's okay. I have more. So let's go after this one first. So this one is going from this point to the chassis. So let's see. I may have better, since my little capacitor is not going to stretch that far. It's got a range more like this. Is there something important about this spot here to connect to? I don't think so. So any chassis terminal within range here. It's pretty close up here. Hey, look, there's a spot right that spot. Now, going onto these fins, how are they attached? They appear to be bolted down. You'd want to know that these fins are soldered to the main chassis. They don't see that anywhere. Except, of course, all this solder onto this weird copper tube, which is supposed to be soldered to the chassis here, but isn't. As we found earlier, it's loose here. Okay, one of my options again. Cut this wire, maintain most of it, bring it around, extend onto here, and can I get all the way up to there? I'm going to be replacing this anyway. Where is there another ground terminal I can get to? I don't see any. So this guy is positive here, ground to this terminal. This terminal is soldered very nicely onto the chassis. So that's an excellent spot there. I'm not going to make it there without a wire. So what I could do is I can put two capacitors grounded on this terminal. One might make it to this wire on its own, and the other one I'll have to put an extension wire on, ground it here, and bring the extension wire over to this terminal. That's the plan. That is, in the meantime, I will find the other missing capacitor, which is probably just right around here somewhere. So I may have mentioned a few videos ago that I'm starting up another channel, and I haven't said anything more about it because it's not going well. It's supposed to be a product review channel, and so far I've had only 2 products to review, so that's why you don't hear me saying any more about it right now. It takes time to get things happening, get things going. Okay, so I'm hoping to put that like that. Bring this lead around. You know what? This isn't going to work because I think I'm going to take a little bit of a different approach. Let's untwist these. Okay, I'm going to cut this guy out now. I'm going to want to test all these capacitors too to see what the story is with every one of them. So I'm leaving his leads behind. In the hopes. Yeah, that's pretty hopeless too, isn't it? So all I'm going to have to do, twist these back together and put an extension onto both the positives. 2 extension wires coming off of here. then they can reach to where they need to go. So I'm going to go ahead and get all that done here. Okay, let's see. Just soldering on the extensions here. There. Oops. Sorry about that. I know that makes sharp noises on the video when I drop my tools. This wire was barely in there. That's the original wire. There we are. Definitely the negative leads on the ground. Good show. This one comes down here. Doing my best not to break any other wires here. Already broke the one on the coil up here. I haven't forgotten about that. The snow is leaving my property now. I think basically I've had snow on my property since about mid-November, if I remember right. The first decent snowfall. I had a couple there in November, maybe early December, and then really you didn't get much snow the rest of the winter. A little bit here and there, but mostly it's been the same snow on the ground the whole winter. Now it's leaving because it's warm and rainy. I can't say I'm sad to see it go. I like weather. I get excited when there's big weather. I don't know. Okay, let me nip this off here. We'll get rid of this capacitor. Gonna leave the wire tail here because I think I'm gonna need it to ground this properly. So I'm gonna cut this off way up here actually. Leave the tail here too. Out you go. 20,450. And the other one was also. I'm sure it says 20. Can't read the voltage, but. Okay, so this guy goes here now. You know what? This wire is barely on this terminal also. So, you know, I don't do the best soldering jobs here. I'm a little better than this last guy. Let's see. Anytime you're doing anything to something like this, you can have unexpected results. Namely, in this case, I have a terminal with a lot of wires connected to it. I just pulled off a couple of unnecessary ones now, but did another wire fall off in behind there and I didn't see it? That's the kind of stuff that can happen. You think you're fixing things when you're actually making them worse. Okay, that guy's in there okay. This guy's on the terminal correctly. Good. Now we're down to the capacitor. It's a capacitor resistor pair up in here, which form the bypass capacitor and cathode resistor for the one output tube that's driving the speakers. This end's easy. The other end is kind of buried in here. Here's another capacitor I'm eventually going to change, but I don't want to do it just now. Kind of in the way here. Let's take a closer look. See what I'm up against here. This guy here and his yellow buddy resistor. Where's the other terminal? I think it's right on that pin. You can see it right. Yeah, I can't point at it. Back in there. I think it's just kind of tack soldered on there, or I think it's original. What do you think? I shove a soldering iron down in there, I'm gambling. These wires here are stiff and cracking. This resistor has a crack in it here, but it may be good, but I may want to replace that anyway. Bearing in mind that I may not have the right schematic. That feels very loose. I'm looking to see if it's did it actually solder down in there? I think it is. I think it's just a surprisingly long piece of wire there. seems to be happy in two different positions here. That's not what you expect. Okay, won't matter anyway because ultimately it's coming out of there. So let's see, I could get this capacitor out of here easy enough. Oh, it's wound around one of the leads of this green thing. It's really hard to see back up in here, just like the way this is done. So they twisted up the resistor lead and the capacitor lead and then soldered them in together. The difficulty here for me is if by some chance my schematic is so different that I really can't rely on it for this stuff, then I don't know how big this resistor is. I can pull it out and test it. Hopefully there's some markings on it. This guy, even if it's not, I can figure out what it should be by looking at books and stuff like that. And you can't go too far wrong with that cathode one. It's going to be a couple hundred ohms. Well, I got to get in there. I'm trying to decide whether I should cut it away or try to desolder it. I think I'm going to try to I got to shove a soldering iron up in there sooner or later anyway. So might as well make it sooner. Move some of those stiff wires. I don't want to do that. It looks like I might get away with cut this and leave some here. I might get away with just hitting it with a soldering iron, pulling on these, they might come right out. Okay, without burning myself or anything else. Appreciate this better from a longer shot. See what I'm doing. Once I get the soldering iron in there, I really can't see much. Burning or melting something. One more try at that. Yeah, I bet you these are original and they're not just tacked in. Give up on that. This isn't much easier. If I push these hard out of the way, I'm pushing these wires down here and they're all going to crack. Can't be doing that. Oh, I got something. Body end dot. Body is yellow. End is green, dot is brown. So starting with the dot, with brown, 1 0. So it's something something 0. So it's in the hundreds. So go back to body and dot. Body, yellow. Isn't that 4? 4, 5, 0. 450 ohms. Hey, I got the schematic right here. Do I? Where is it? Here it is. It's R11 and C32. R11, 5,000 ohms. Wow. Okay, that's a lot different than what I just figured out by looking at it. And C32, was it? C32. 3210. Okay, so I got the 10, 25 volt correct. If I can find the capacitor, which is still missing. Thank you. Shadow. Let's just. Ooh, that just, yeah, that's okay. I was gonna say it fell right off, but that's okay. Now they're separate. Let's test this. Try it with this guy. Body and dot. Dot is definitely brown. Brown is 1. This is in the hundreds. Oh, let's see. 611. And I'm thinking it's 450. It's reading 611. I really have no reason to doubt it. But I do. So let's get. Here we are. Here we are. Here we are. Here we are. Let's get another meter. Got to pick this fairly correctly because the value of the resistor controls the biasing on the output tube. If you bias the output tube wrong, there'll be too much current flowing through it all the time, even when there's no sound. And you'll end up cooking it. $611 on the other one, 604 on this one. So 600 is what it is. Now, how come when I study it, why don't I get like yellow? Yellow is 4, isn't it? Yellow 4? Am I crazy? Well, I am crazy. So we got 5,000 on the schematic for a tube called a 19. Doesn't have a 19. The tube that this is attached to is the, oh my gosh, it's not what I thought it was. Holy smokes. Okay, hold on, hold the horses here. So there's a 6F6 up there. 6F6, I'm pretty sure that's an output tube. That's a power tube. Right next to it is the other tube. So I figured the 6F6 is the one that's driving the output. And it would be the one with the bypass cathode resistor, all that kind of stuff. Maybe there's another cathode resistor bypassing thing going on in here. Maybe the two of them are using the same. No, they're not using the same one. I don't know. It's just more mystery, no schematic. Gotta wing it here a little bit. So the output tube is a 42. I gotta look that up. I don't know much about. I think a 42 is a very rare tube, in fact. I'm not so sure. 42. Power pentode. Glass type used in audio output stage of receivers. Tube requires 6 contact socket. Heater 6.3. Oh, this type is electrically identical with type 6F6. type 42 is used principally for renewal purposes. What? You replace a 6F6 with a 42, it requires a different socket. Now my head is really exploding. My head is coming off here. You've just got so many mixed messages now of what is going on in this radio. Let me just show you. I'm not crazy. I'm not crazy. So I'm taking out the 42 here. You look in the socket. It's meant for this kind of tube. No post. Never noticed it has a little arrow there between the two heater pins. No post. 6 pins. 42. Made in Canada. But internally, you won't be able to see it too well there through the camera. But internally, structurally, it looks the very same as this, which is why I thought this was push-pull and 2 identical tubes to start off with. Why, how? Okay, you know what? There's rivets here. These sockets are riveted in. Did somebody change out a socket and then rivet in a new socket in order to get away from, I would think you get away from the 42, but it says the 42 is renewal. Six F6. 6F power pentode. Use audio output. Large power output with relatively small input voltage. Line 6F6 may be supplied with pin 1 omitted. In other words, you look at the bottom of the tube, it may not even have a pin number 1 sticking out of it. Tubes require octal socket, mounted in any position. They need to be adequately ventilated. 6F6 and 6F6 GT are used principally for renewal purposes. Why are they renewing the 42? Doesn't say anything about 42 in here. Push-pull Class A amplifier. How do you end up with a radio with what should be, if this is really push-pull, there has to be a transformer associated with it. There's no transformer here. Can't be the transformer up on the. I'm pretty sure you need a center tap audio output transformer to run a push-pull system with 2 tubes. And there's no such transformer here. So maybe we can tell, well, like here's the speaker terminal, here's the tube closest to it. Okay, now that's not really powerful logic, okay, but this is probably the tube that's driving out the connector. Then what's this one doing over here? The 6F6. The 6F6 is driving the 42. Really? I'd have to get in there and kind of sketch out the circuitry. Or there's an audio signal coming from the radio, which is on its way to the speaker. It's going to pass through these 2 tubes. It's got to come up and find one of them first, then the other one, then the speaker. So can I spot that audio line? It's probably a shielded wire. So we're looking for a shielded wire, for instance, coming to the grid of this tube here. Or This appears to be wired in the most simplest way. What's going on there? It's got one. It has only two wires coming to it. Really? Only two wires coming to it? And the terminals are... There's two wires coming to it at the top here. One ends here, the other one ends here. This terminal is connected to here. These two resistors then come out to these terminals. What is this? I'm going to look up 6F6 in the book again. I'm going to get the pin out, spot the plate in the grid, see what's going on. 6F6, plate is 3, signal grid is 5. 3 and 5. 3 and 5. 3 and 5. Camera's not cooperating here. 3 and 5. Okay, so there's the key. 1, 2, 3. This is 3. 3. That's the plate. There's nothing connected to it. Three. 4 is kind of hidden under here. 4 has no there's no binding post on 4. 5 is here. You can see the two pins sticking through where there's no post to receive it. There's no. That's pin number 4. What's up with pin number 4 on this tube? Let me look quickly at the diagram here. Pin number 4. Pin number 4 is it's one of the grids. It's the screen grid. Number 4 is a screen grid, a 6F6. That's definitely the 6F6. Everything's looking right here, except it's all looking wrong. So if that's the screen, like this isn't even wired for this tube. There's no signal reaching it. There's no output from it. Wow, this just gets weirder and weirder. Look, there's a big spot here with solder on it. People don't put solder on a chassis for no reason like that. I think you can see a little piece of wire sticking out of it. What has happened to this radio? Well, I know I don't know what to do here. Just carry on. Just carry on doing what I was doing. Just replacing the resistor of a value that is maybe 600, is maybe 400, is maybe 5,000. capacitor that was in there. No more. It says 25. 25 microfarads. "25 microfarads, 25 working volts." I like that working thing. 40 VSF. Very sudden voltage swing factor. Made in the US of A. I live in Canada of A. Can't quite read what it says right at the bottom there. Not that it matters much. Who made it? Minican, I guess Minican Solar Minican. Never heard of these guys. Who knows? Now, did I really take proper note of which end is? Yeah, of course. Where this was, have I already forgotten where it came from? No, it came from here. Came from here and went to there. Okay, well, let's check that. Let's check what this pin is on the 42. I haven't looked at the 42. What if they've got the wrong tubes plugged in here? What if they've looked at the wrong schematic like I am and they're making their best guess and that's all it is and it's wrong? They've stuck tubes in here. What if somebody's rewired this chassis to what? To, I don't know. Okay, so 42. So this one here, it's a little different counting the pins on this one. We have to spot I think these are the two heater pins at the bottom here. Pretty sure. So I think this is pin 1. 1. So that would be 6, 5. Pin number 5 on the 42 is the cathode. Now that makes perfect sense then, doesn't it? Because I have the cathode resistor and capacitor. So that adds up beautifully. The plate is coming off of pin number 2. Pin number 2, a little hard for me to see it there. Must be one of these wires here. Pin number 1, 2. 2 has a couple wires. This is really cockeyed. This is really cockeyed. So I know it's a bit of a long shot here with the camera, but the pin number 2 plate, this wire comes all the way over to here, meets this terminal, meets up with this capacitor. Oh, goes up to here. Okay, I thought this was going to go to ground, but this goes to the tone control. Okay, so that's the tone control. Okay, so that's why the wire comes way over here. The other wire, there's 2 wires off that pin, goes to the speaker. Goes to the speaker plug. Well, I don't know. I don't know what to think. Yeah, wow. Who would have thought this would happen? Oh, I wanted to look at the proper plate resistance for the 42. I missed that. 42. As recommended in here. I mean, it depends upon the circuitry of this particular radio in the end, what you use. Oh, this isn't going to say. It says it's identical to the 6F6. Electrically identical, so we'll go to 6F6. Where's F in the alphabet again? 6F6. This should give us a plate resistor here somewhere. Just gotta go down all these different plate resistance approximate. What? 80,000 ohms? A little higher, if you put a little higher, put 285 volts by B plus on it, you want it slightly less. Plate resistance, 78K. It's a big number. You can't read it. You can see there's a lot of digits in it. That's not helping at all. Plate resistance. You know what? Maybe I'm reading this wrong, because here it says load resistance. It's not much better. 7,000. That's closer to 5,000. But it's nowhere near 600. Oh, you know what? This isn't the plate load. What am I looking at? Okay, everybody can calm down. Calm down. Jim's caught up with himself. I really want to be looking at the cathode bias resistor. Yeah. 410, 440. Yet the schematic calls for 5,000. Why? Oh, that's because the schematic shows a different tube on like 19. No, actually it shows this 6C5. 6C5. Then there's the push-pull transformer, and then this is a double tube here to handle the double-ended situation. This cathode resistor here is not on the output tube, it's on this driver tube. But I'm just massively confused. Holy smokes. Yeah, maybe looking at this schematic is really not helping much at all. I might as well look at any radio schematic, let alone this one. It's really, really weird. Weird for me, anyway. Where is my cat and capacitor? Where did he go? What did he do with it? I may have hockeyed it away for good. I may never find that little capacitor again. Make a quick look on the ground here. I can just imagine my cat running through the house with that thing sticking out of its mouth. My cat Shadow takes his toys. She takes her toys to different parts of the house to play with them. She'll pick it up and run through the house to some other area and play with it there. And then we'll see a little pile of her toys. The toys are usually little foam balls, not much else. I have a fantastic cat toy. I got one right here. I gotta show you this. I've had cats for a long time. Never had this kind of toy. Okay, it's just a spring. I don't think there's any metal in it. It's just a piece of coiled plastic. They love this thing. They just love these. We have like 10 of these around the house. And the great thing about them is if you come along and step on it, it just goes flat. Right? So, yeah, if you've got cats and you've got cat toys and you've stepped on cat toys, you know what I'm talking about. So anyway, my wife got these. I don't know where she got them from, but it's just a cat store. I think the pet store. Super fun. Even I have fun with them, for crying out loud. But that didn't turn up the capacitor. I gotta dig another capacitor out here. $10 at 25. Sounds about right to me. C32, I think this shows up as 8 or 10. C32, 10. 10 at 25. Okay, so that's good. And then I need a fairly high wattage, 600 ohm. $400. 450 ohm. 450 ohms, kind of a weird number. Okay, I gotta dig around to try to find something like that.